Good morning, you guys. I hope that you're having a great Thursday. I'm not here with you. I think I told you that I wouldn't be here again today. I'm sorry. I know I miss a lot, it seems, and I promise once golf season is over, you guys are gonna see me more than you want to. But, anyways, y'all are gonna have a pretty easy day today because tomorrow you're gonna have a small little quiz. Um, so we're going to go ahead and get started, and hopefully you guys will be prepared for the quiz tomorrow. I think you will for sure. So let me pick up where we kind of left off. I know that yesterday was crazy trying to catch back up from what had happened in class on Tuesday, where you guys learned how to factor the sum and difference of cubes. Y'all already knew the rest of them, and you guys are smart, so really probably was something that you just needed a quick refresher on. And then the sum and difference of cubes was an easy learn. So I want you to check out the answers I have here so far. And while you're looking, I'm going to go ahead and do a couple of these with you. I just kind of handpicked some that I thought were maybe a little bit more complicated, and wanted to go through those to make sure you follow along and understand. The first thing I recognize, guys, is that these are x cubed and y cubed. They're multiples of 3. The only thing I'm possibly checking here is to see if they're sum of cubes. Now, if you have that little list with you, you don't see 54 and 250 on it. And the reason is because this problem in particular had a greatest common factor, 2. And you need to take it out because then it creates it to be 27 x cubed plus 125 y cubed. And now we are dealing with perfect cubes. Okay, 27 and 125, you see those on your list. So sure enough, this one will factor into a binomial times a trinomial. And again, I'm going to leave that room to do it, and then I'm going to do it. So my binomial. What multiplies by itself 3 times to give me 27x cubed? Well, that's 3x. What multiplies by itself 3 times to get 125y cubed? 5y. So those are my binomials. Now, hopefully you guys recall from yesterday and the examples that you saw already, the outside terms, okay, my ends, we take these values and we square them. What's 3x times 3x? 9x squared then should be here. What's 5y times 5y? Well, that's 25y squared. So that's what you should have on your ends. Now, what about right smack dab in the middle of your trinomial? Well, it's a times b. That's 3x times 5y. Well, 3 times 5 is 15, and x times y is xy. So that's what goes right in the middle. Now, hopefully you guys recall, if that's a plus sign, remember, the binomial has to mirror that. It's a plus sign too. And to offset it, this has to be a minus. What did we say about that last term? Always positive. And there you have it. You can't factor anything any further. So hopefully you guys had that one right. Hopefully, if you did not, you follow along. Let me show you 8 and 10. Number 9 is a doozy. I'm going to do 11 first. Okay? Now with 11, I know that 9 is a perfect square, and I know that 144 is a perfect square. But check it. You're always supposed to check to see if there's a GCF. And sure enough, if you don't know this, 9 goes into both of them. But this has y the 7th, and this one has y. So we actually can take out 9y. So let's do that. 9 divided by 9 is 1. Y to the 7th divided by y is y to the 6th. Negative 144 divided by 9 is negative 16. And then, of course, lastly, y divided by y cancels. So here's the deal. How do I know whether this is cubes or squares? Well, 6 is a little deceptive because that's a multiple of 2 and it's a multiple of 3. So it technically could be. But it's 16. 16 is not a perfect cube, is it? Nothing will multiply by itself 3 times to get 16. but it is a perfect square. So this is going to be treated like difference of squares. So I'm going to factor it into two binomials. What multiplies by itself to get y to the sixth? Well, that's y cubed times y cubed. What multiplies by itself to get 16? 4 and 4. And of course, the rule of difference of squares, one is plus and one is minus. Now, can I go further with those? No, because even though these are perfect cubes, the y cubes, 4 is not. So therefore, I cannot. And I know that this is difference and 4 is a perfect square, but y cubed is not. So this one cannot go any further. Now, number 9, I saved this one for last. This is a crazy one. Some of you guys I know saw it yesterday. Look, there is a GCF. You can pull out an A, and you can pull out a B squared, which really doesn't leave me with much. It leaves me with A to the sixth minus 1. So the reason this one's tricky is because you kind of have to look at this and say, wait, couldn't A to the sixth minus 1 be difference of squares and difference of cubes? Absolutely. But we're going to start with difference of squares here. Here's why. Because A cubed times A cubed gives me A to the sixth. And then 1 times 1 gives me 1. 1's a plus and 1's a minus. Now, a lot of people would get to this point and be like, oh, well, we're done. No, we're not. Here's why. Isn't that a perfect cube? Isn't that a perfect cube? These are both perfect cubes. This is sum of cubes. This is difference of cubes. So we actually can go all the way down where we take this to a binomial times a trinomial, and we take this to a binomial times a trinomial. Crazy, right? So let's do it. What multiplies by itself to get A cubed? A. What multiplies by itself 3 times to get 1? 1. Then we square A squared. We square 1, 1 times 1, 1. We multiply A times 1 is A. If the original is plus, this is a plus, this is a minus, that's always a plus. So that one's done. So now we go to this one. Same deal, right? A and 1. A squared, 1, and A. If that original one here was a minus, this is a minus, this is a plus, this is always a plus. So crazy, but that is our process for number 11, or number 9, I'm sorry. So I told you that one was kind of tricky. All right, so there you have it. Very good, very good. Let's move along. 12 and 13 I went ahead and wrote. Remember, you can't take this any further because it's not difference of squares. I know they're both perfect squares, but W is not. The 4 and the 9 are, but the W is not. Here's number 13. These were easy. Shouldn't have any problems with this. Let me do number 15. It's got a couple of little tricks to it. So first, it's just a trinomial. It doesn't have any GCFs. So we're just going to break it out into two binomials. So what multiplies by itself to get W to the fourth? That's W squared. What multiplies to get a negative? Positive and a negative. So we're looking for two numbers that multiply to get 32 but have a difference of 14. Well, that's 16 and 2. Now, what sign wins the middle? Well, definitely 16. So 16 has to go with the minus and 2 has to go with the plus. Well, because I did that, W squared plus 2, that's done. Okay, that's a perfect square, but this is not. But W squared minus 16, that's difference of squares. So I'm going to take that down to two more binomials. Remember, W times W, 4 times 4, 1's plus, 1's minus, and that one is complete. So here's 17. That one I did for you, easy. You can check it out. Make sure you got it right. Okay, hopefully you did. You can follow the work if you did not. Here's number 20. It's a lot going on here. Okay, I pulled out y squared, GCF, then I did over, under. So 3 over 9 reduces to 1/3. So those ended up 3y squared plus 1 and 3y squared plus 1. Okay? All right, let's look at number 21 together. There is no GCF, is there? No GCF. It's got a number 8 in front, so I'm going to over, under. Over, under. So here we go. C to the 4th plus 10c squared minus 24. So we're going to factor this easy style. So that's c squared plus minus, right, to multiply to get negative. So we're looking for the two numbers that multiply to get 24 but have a difference of 10. Well, that's 12 and 2. 12 and 2 have a difference of 10. Positive wins, so it has to be plus 12. It has to be minus 2. But please don't forget, we did the over, we got to do the under. Got to do the under. So with this one, 12 over 8 reduces to 3 over 2. 3 over 2. So that's 2c squared plus 3. And 2 over 8 reduces to 1 over 8, or I'm sorry, 1 over 4. So that's 4c squared minus 1. Because you got to reduce it if you can. So let me just write it, just so you guys don't get confused. That's 3 over 2, and that's 1 over 4. Now, here's the only deal with this problem. It's not done. I want you to look at that. This one's done, for sure. I can't do anything with 2c squared plus 3. But this is the difference of two perfect squares. What multiplies by itself to get 4c squared? 2c. Of course, what multiplies to get 1? 1. 1's plus, 1's minus, and now it's done. So that one was a little trickier. That's why I wanted to show it to you. Here's 22 and 25. But let me do 23 and 24 with you. Again, this is my favorite method of factoring. It's factor by grouping. So we're going to group these. And there's a reason why I chose both of these. So first one, let's take out any GCF you see in that first group. It looks like it's just r squared. So 4r cubed divided by r squared is 4r. And negative 3r squared divided by r squared is negative 3. That's the first group. Don't forget, I told you whatever that sign is needs to come down first. And of course, here's the reason I wanted to show you this. We kind of ran into it right here. But will anything come out of 4r or 3? No. See, I got this minus sign here. You got to pull something out. So if there's nothing to pull out, you pull out a 1. So we're pulling out a negative 1. What is negative 4r divided by negative 1? Well, that's positive 4r. And what's positive 3 divided by negative 1? Well, that's negative 3. And sure enough, what's left inside these are the same. So our factors are what we pulled out, look, r squared minus 1, and then, of course, what was left inside. Another reason I showed you this one, besides this understanding that whatever, when there's not something to pull out, there's always something to pull out, a 1. You also have difference of two perfect squares here. So this will break down into two more binomials. Now 4r minus 3 will not. So we've got r and r, we've got 1 and 1, we've got plus and minus. And there you have it. Okay, last one, and I really don't know if there was a great reason for 24, but just one more to do with you. Factor by grouping. All I can pull out of here is p squared. That leaves me with 3p plus 5. Always start with the sign, minus, in this case. See it? What can I pull out of 12 and 20? Well, that's a 4. So negative 12p divided by negative 4 is 3p. And negative 20 divided by negative 4 is positive 5. So sure enough, these are identical. 3p plus 5, 3p plus 5. So our factors are what I pulled out, p squared minus 4, and what was left inside, 3p plus 5. Again, kind of like this one. here's difference of squares. So this factors into two binomials. And then don't forget 3p plus 5 comes on down. So that's p times p, that's 2 times 2, that's plus and minus. So p plus 2 times p minus 2 times 3p plus 5. Okay, so you guys are going to be working on a little review for a quiz. That review I have left up on my desk. In fact, as soon as I walk away and stop this recording, because it's 15 minutes, I have put this answer sheet on the top shelf of my podium where I sit all the time. I'd like for you to check those and make sure you have all the correct answers before you walk out of class. Make sure you understand how to do those. If you missed one, talk to one of your neighbors, because y'all have a good solid 30 minutes right now to review for the quiz tomorrow. Literally, we're going to come in. I might give you a moment to ask me for some questions, but not much, because you have 30 minutes right now, or close to it anyways. So I want you to come check it. I want you to talk to your neighbor if you're struggling, and be ready for a little factoring quiz tomorrow. Okay? Hey, have a great Thursday. Can't wait to be back with you guys tomorrow.